Hello and welcome to this C++ chapter. Today we are trying to understand operators. To do this, we are using the example of someone who wants to use the bus. There is a control. You are the controller and you want to know for each passenger how much the trip costs. In one case, the passenger has paid the ticket. In another case, the passenger has not paid the ticket. The ticket costs 2 euros, whereas a fine costs 135 euros. So either a trip costs 2 euros, the price of the ticket, either it costs 135 euros, the price of a fine. Like we have seen in the previous chapter, a Boolean can store either the value true or the value false. Here, a Boolean is used to know if a passenger has bought a ticket or not. If the traveler has bought a ticket, the price of his trip is just 2 euros. So for an equation that looks like cost is equal to cost plus Boolean times 135, we want the Boolean to be equal to false, that is to say 0. This way, the equation will look like cost is equal to cost plus 0 times 135. In other words, cost is equal to 2 plus 0 times 135, leading to cost equal to 2. Indeed, the traveler has bought his ticket. So, for a Boolean that needs to be equal to false when the passenger has bought his ticket, we can call the Boolean something like unpaid. This way, it is equal to true when the passenger has not bought the ticket, and equal to false when the passenger has. But a Boolean that is the negation of something is rather unclear. It sounds better if we can call the Boolean something like has bought a ticket and use its negation in the equation. The operator exclamation point is the C++ operator for the Boolean operation not. For clarity, we set the Boolean equal to has bought a ticket, and we use its negation in order for us to have 0 times the price of a fine when someone has already bought a ticket. The equation now looks like cost equals to cost plus not has bought a ticket times fine. On the other hand, we want to have the Boolean equal to 1 when the passenger has not bought a ticket. Again, we can see that the negation of has bought a ticket works here. Indeed, for someone who has not bought his ticket, the value has bought a ticket will be false and equal to 0, whereas the negation of has bought a ticket will be equal to 1. Indeed, cost is equal to 0 plus 1 times 135. So cost is equal to 135. We have just seen an example that uses the addition, the multiplication, a Boolean, and the negation of a Boolean. Now let us look at the operators in a theoretical point of view. An operator is something that we use with one or several variables or constants. A variable is some space in memory that contains a value that can change, whereas a constant is some space in memory that contains a constant that cannot be changed during the program. Here you can see different operators. Here are all the main operators. You can recognize the addition, the subtraction, the multiplication, and the division. To express the price of a bus ticket, we use the equal operator that assigns a value to its variable. Price of a ticket is equal to 2. With coding, we assign values from right to left. Here, 5 is assigned to the variable x. Then the value contained in the variable y is assigned to x. Then 5 is assigned to the three variables x, y, and z. Here are the arithmetic operators. They just look like our mathematical friends. It's just the modulo operator that is a bit complicated. So the modulo operator is one of the most complicated ones. It is represented by a percentage sign and gives the remainder of a division of two values. It is mainly used to know if a number is even or odd. Indeed, an even number divided by 2 gives a remainder of 0, whereas an odd number divided by 2 gives a remainder of 1. So if you need to do calculations in your program, you do not need to learn much, as the classical mathematical operators are then being used. So here are the compound assignment. This is just a way to concatenate the code. If you are new to programming, I would recommend to explicitly write what you want. For instance, use x is equal to x plus 5 if you want to add 5 to x. And if you're more comfortable, upgrade to x plus equal 5. In our example with the bus, plus equal can be used to determine how much a trip costs for each passenger. Indeed, the equation is cost equals to cost plus not has bought a ticket times 135. So, cost plus equal not has bought a ticket times 135 is a valid way of writing the equation. Now let us look at the increment and decrement operators. Cost plus plus is equal to cost plus equals 1 is equal to cost equal cost plus 1. Minus minus is equivalent to minus equal 1. So cost minus minus is equivalent to cost minus equal 1, which is equivalent to cost equal cost minus 1. That is another way of concatenating our code to make it look more professional. Relational and comparison operator. So you can see it's equal, different than, greater, lower, greater or equal, lower or equal. So in the case of integer a is equal to 2, integer b, we have, so we read from right to left, 2 is equal to b equals a. So b equals a, it means the value of a goes into the value of b, and the value of a is 2, so 2 goes into the value of b, and then this, so the value of b equals a, so that is 2, b equals 2, equal to, that is true, because b equals a leads to b equals 2, and is it equal to 2? Yes, it is, so it is true. Relational and comparison operator. Two expressions can be compared using relational and equality operators. For example, to know if two values are equal or if one is greater than the other. In the case of our friend who travels with the bus, we could use the equal operator to know the value of some booleans. and the booleans could be has bought a ticket and there is a control. So there we look at the example with another point of view, with another angle. We write Boolean has bought a ticket is equal to true. Boolean there is a control is equal to true. The price of the fine is equal to 0. If there is a control equals to true, which is the case, then you go into the other expression. If has bought a ticket equals to true, then fine equals to 0. Else, fine equals to 135 if the person has not bought a ticket. Else, if there is not a control, fine equals to 0. Now, let's have a closer look at the logical operators negation and or. So when there is a negation, it gives you the opposite of what you have. If you have true, then you have false. If you have false, then negation of false is equal to true. And means you have both things. Both things are true. For instance, true and true is equal to true. True and false is equal to false because we don't have both sides equal to true. False and false is equal to false because both are false. False and true is equal to false again. Now, like we have just said, the opposite of true is equal to false. The opposite of false is equal to true. And then on the right side, you have true or true is equal to true. True or false is equal to true. Because we can choose between true or false, so we choose true. False or true is equal to true. It means one of them is equal to true. False or false is equal to false. I leave the explicit typecasting operators for another lesson. Thank you for having paid attention to this tutorial, and bye!